This is a lesson video for chapter 10, part 2. In the fourth section, delete rows from a table, we're going to cover removing rows with delete, use the delete command, removing rows with truncate, and merge. We come to the first delete example, and we're going to remove a record. So let's go to SQL Developer. If we go to SQL Developer and we look at the regions table, we have a region ID 206 and it's Iberia. This is the record that we're going to delete. So we use the keywords delete from the table name, the where clause, region ID, and 206. So we're going to remove this record. So I run this statement and I deleted the record. I got a message that it was successfully deleted. I refresh the table and 206 is gone. Now we come to an exercise where we're going to see more delete examples. The first example, we're going to delete again from the table's regions. We're going to use the keywords delete from. We're going to use the where clause, the column which is region ID, and we're going to delete record 204. I'm sorry, record with region ID 204. So we're going to delete this record here. So we execute the SQL statement. We got a message that a record was deleted. We do a refresh and region ID 204 is gone. Okay. In the next example, we're gonna let's go back to SQL Developer. So we go to we're gonna omit the where clause. So we're gonna try to delete all the records in the region. If we don't specify what record we're gonna delete, it's gonna attempt to delete all the records in the table. So we're gonna run this, and we got an error message that says integrity constraint. So we have a foreign key constraint that links our regions table to our countries table. So we have a region ID in countries table, and a region ID in regions table. So because these are linked, and there's a primary key that constraint that links these two fields. So I'm going to go to constraints, and here we have region ID. This is the primary key, so let me go to countries, and here we have country region, and it's got a foreign key, so it's linked to the regions table, so we cannot delete the records because it already used up region ID. So that's the reason we cannot delete all records. Okay, so we go to the table of regions, and you'll see the records were not deleted. If we didn't have that primary key, the records would have been deleted. Okay, the next example, we're going to use a subquery, and basically the subquery is going to say that all the region names that have Iberia are going to be deleted. So we have one record that still has Iberia, so we're going to delete this record with a subquery. It's basically saying all the records that have a region name Iberia, delete. Okay, it said that one record was deleted. So we go to our data and we refresh. You'll see that the Iberia record was deleted. Okay, our next SQL statement, it just basically checks our table. We run it, and these are the records that are left, and we don't have Iberia here. The next statement, we're gonna have to commit, so we make all our changes permanent. Alright, commit. So when you're doing your homework assignment for this chapter, make sure you commit, so all your changes are permanent. Now we go to removing rows with truncate. This is also I'm gonna run it, but it's gonna give me an error because it's got a foreign key constraint with countries. Again, it gave me the long message, and it's basically says a primary key referenced by a foreign key, so on and so on. So if it didn't have that foreign key constraint, it would have been deleted. So we use truncate to delete records in the table. Now we come to control section, transactions. In this section, we're going to cover database transactions and the transaction control statements. Any relational database must be able to pass the ACID test. It must guarantee atomicity, consistency, isolation, and durability. The principle atomicity states that all parts of a transaction must complete or none of them. For example, if your business analysts have said that every time you change an employee's salary, you must also change the employee's grade, then the atomic transaction will consist of two updates. The database must guarantee that both go through or neither. If only one of the updates were to succeed, you would have an employee on a salary that was incompatible with the grade, a data corruption in business terms. Now we come to consistency. The principle of consistency states that the results of a query must be consistent with the state of the database at the time the query was started. Imagine a simple query that averages the value of a column of a table. If the table is large, it will take many minutes to pass through the table. If other users are updating the column while the query is in progress, should the query include the new or the old values? Should it include rows that were inserted or deleted after the query started? The principle of consistency requires that the database ensure that changed values are not seen by the query. It will give you an average of the column as it was when the query started, no matter how long the query takes or what other activity is occurring on the tables concerned. Oracle guarantees that if a query succeeds, the results will be consistent. Isolation. The principle of isolation states that an incomplete, that is, uncommitted, transactions must be invisible to the rest of the world. While the transaction is in progress, only one session that is executing the transaction is allowed to see the changes. All other sessions must see the unchanged data, not the new values. Durability. The principle of durability states that once a transaction completes, it must be impossible for the database to lose it. During the time that the transaction is in progress, the principle of isolation requires that no one can see the changes it has made so far. But the instant the transaction completes, it must be broadcast to the world, and the database must guarantee that the change is never lost. A relational database is not allowed to lose data. Now we come to commit. commit makes the changes permanent and visible to other sessions. In our examples, we've used commit several times, and make sure you run your commit after you inserted records or you make changes to your records. Now we come to rollback. In this example, we first truncate the table, so it means we delete all the records in the table, and then we insert one record, and then we do the first save point. So this is, it marks where we're at the current table. Then we insert a second record, and then we do a second save point, and then we insert the third record, and then we do a rollback to second. So that means we do a rollback to the second save point. So this, we come here to the second save point, and we shouldn't be able to see the third insert record. And then we go to rollback, we go to save point, first save point. So that means we go up here, and then we shouldn't be able to see the second or third inserts. Okay, and now we go after the save point first, we do commit, and then we delete from table 1. At this point we delete all the records, and then we go to rollback 1, and this is up to the first at the first save point. So we go back to here after the first record was inserted. So at the end we go to the first rollback, which is the one record inserted. Because it's after commit, everybody else should be able to see the insert. That concludes the lesson video for chapter 10 part 2. Thank you for watching.